what we'll do today is the panelists, thank you, are sitting up here in order of their presentations, and they each have about 5 minutes to do a presentation. And then we'll do some conversations amongst ourselves. And I think we have a clicker for you, Brian, if you want to use it, or, yeah.
Whatever's easier. Yeah. Sure. Okay.
Or you can get up and walk around. It's up to you.
Fine. However, I would stay right here. Okay. Well, so thanks a lot. I really appreciate being able to participate in this conference. I think to motivate my contribution here today, I'd like you just to imagine being the commander of a joint task force to stop piracy off the coast of East Africa, and these are real type of missions. First of all, you will recognize that you really need to first make sense of this complex situation before taking any actions. Now, that doesn't always happen, but you really want to do that. So, for example, before just going out and sinking all the pirate boats, that actually could make the problem even worse. So you really need rapid sense-making, and you turn to machines for assistance. So you could start by asking Siri, how do I stop piracy off the east coast of Africa? Well, you can imagine what Siri might say. It comes back with references on piracy on East Africa. And, because it gathers it from the web. And you really start to come to the conclusion this isn't going to work given my mission timeline. So we want machines to help us in making very quickly sense of complex scenarios, situations, environments, while at the same time we want these machines to do better at making sense of what we're asking. So our office at DARPA, I'm the Deputy Director of the Information Innovation Office, we have a number of programs that we're trying to at least address these needs. So let's just begin by framing the sense-making process within the well-known data wisdom hierarchy. And this hierarchy is shown here as a chart with data at the origin, with increasing axes in A, sapience or reasoning, B, abstraction or data compression. And one can see information as the who, what, when, where, knowledge as the how, understanding the why, and wisdom as sound judgment leading to actions. Now, I make data lowercase here, really to distinguish it as the raw material on which this hierarchy is built. This chart is an illustration of sense-making presented as a two-way flow between data and wisdom. So if you start on the right, that generates hypotheses, which can lead ultimately to the collection of data that supports or revises these hypotheses. And that's an example of abductive reasoning, actually stated so well earlier by JSB. If you launch from the left, that commences an inductive sequence that I'd argue complements this opposing flow. So here we have, looking at, before we had machines, humans handled all tasks across the data wisdom spectrum. Machines today perform lower-level data and information processing tasks, thereby freeing humans to concentrate on higher-level endeavors involving knowledge, understanding, and wisdom. Now, in the future, we'd like to see how machines can collaborate with humans to really work at the upper end of this data wisdom spectrum. So this takes us to this chart where really we map current programs in our office onto the data wisdom hierarchy and the sense-making process. So as an example, the leftmost or first program in the information knowledge band is a program called Insight. It's nearly completed. It developed a multiple source correlation and fusion engine that really helped enhance battlefield situational awareness. If we move up to the knowledge understanding band, the first program there is one actually we're just starting, and it's called active interpretation of alternate, disparate alternatives. It's a mouthful because the PM was looking for a particular acronym of AIDA. And so this one is seeking to develop a multi-hypothesis semantic engine that will generate explicit alternate interpretations of situations, events, trends, using a variety of unstructured sources for use in noisy, conflicting, and potentially deceptive information environments. And finally, in the understanding to wisdom band, the first program is Big Mechanism, which is developing machines that can read thousands of research abstracts and papers, extract pieces of causal mechanisms from these papers, assemble these pieces into more complete causal models, and then reason over these models to provide explanations. So insight, active interpretation of disparate alternatives, Big Mechanism are example of programs to develop machines to help us in rapid sense making. Now, the last program at the top here, at the upper right, is 9, and that's communicating with computers. And it's a step towards really helping machines do better at making sense of us. Thanks a lot for your attention.
That was amazing. Thank you so much.
Sure.
Well, this is really an exercise in how well do you know your own slides, because I'm right in front of you. I'm going to get up and move around, though. You did a great job.
Try.
You have eyes on the back of your head.
We try.
So, good morning, everyone. My name is Ajay, and I lead a lab called Digital Life Lab at Fujitsu Labs here in Silicon Valley. We're a few miles south of here. I want to start with a perspective that sort of we'll build on in the next few minutes. We all live today in an era where computing elements are small and powerful enough that they are embedded in the analog world. And as they're embedded in the analog world, this world becomes digitally readable to this digital infrastructure. So when you put computing elements in my watch or my socks, the infrastructure knows how well I'm moving, how well I'm sleeping. Is there some onset of tremors that might indicate a neurodegenerative disease in the future? If you embed these elements in my toothbrush or in my car, they know how well I'm doing with dental health, with my driving behaviors. And with things like cameras and always-on listening devices present in our environment today, this computing infrastructure is always also sensing the environment. So sensing humans, sensing behaviors, and sensing the environment is what the digital infrastructure takes as granted today. So what do we do with these new digital senses? They certainly enable better digital systems. So if you have a car or an energy infrastructure or a home, the computing elements in those scenarios send data to other computing infrastructure, which, going through the hierarchy Brian was talking about, takes that data and that digital sense of data into digital insights and creates data-driven decisions and sends them back. And if it sends them back to chips, which can act on those decisions without thinking any more than just to actually realize the decision into actions, you get digital actions towards desired outcomes. You have cars that do collision avoidance. You do automatic demand response in energy infrastructure. And you have homes that are more energy efficient and more secure out of that. So more data leads to better decisions in essentially all digital systems. So this is really good. But what about all of us as we live in this whitewater rafting world where there is data coming at us from many different spaces, and we are fundamentally still decision-making elements in really big ecosystems around the world, big in terms of global footprint, big in terms of economic footprint. So think about healthcare. It's almost a $5 trillion industry just in the United States. But think also of education and your own behaviors around how you use energy. Personal finance, ways in which we socially interact with each other in enterprises or in scenarios where we're providing customer service. In all of these scenarios, we do now actually have more data and more data-driven decisions created by computing infrastructure that is piped to us, but we are then fundamentally the unit that has the agency and the choice to accept those decisions as not. So it's not clear to me that more data really leads to better decisions for humans in the loop if it's just data presented in the way that it's presented to machines. And the human actions that we wished would lead to desired outcomes just because the machine computed a better decision for us, that loop is not completed fully. So what we envision or imagine is a world where you have ambient technological systems all around you that meet this data for you. So instead of you meeting the data immediately, they meet this data for you. And instead of decisions, they're focused more on something else. So let's sort of say that their goal is really to provide a productive framing of this data. And it could be productive from a cognitive experience of the world. It could be productive from a behavioral experience, action and experience of the world. And so at Fujitsu Labs globally, we sort of fundamentally believe in not just data science, but also blending that with the cognitive sciences to bring this kind of vision into reality. So these digital systems are continuously sensing us to engineer our awareness. Maybe I should be aware of something right now. Engineer our own experience of that awareness so that we can associate a certain amount of tonality to it, which further leads us to engineer how well we will recognize it on our own in the future. Well, we've recognized an experience, we recognize some new data. What is the right mindset by which we form our decision? And finally, engineering the decisions themselves. So our vision at the lab, and this is sort of realized through some projects, is to essentially think of the machine as something that augments our own sense, leading essentially to more mindfulness because we've sort of outsourced that or asked the machine for help in getting to that place. I'll give a couple of actual examples and projects that sort of are fit within this vision. So at our lab here in the Valley, in a project, we sort of built what we consider sort of the best-in-class real-time psychophysiological stress algorithm. And you can pick that up these days from a lot of wearable sensors, such as a chest strap that you might wear. And this is data on a drive that was collected, which mashed up that computed stress data with location using a sensor fusion platform we have called the Sprout. And so our lab we are right now right here. And our lab is just a few miles down south in Sunnyvale. I live here in the city, and this is slides from several years ago. This is from when I was actually working on this project. So, you can see that this was a bit of a late night, and I'm heading back up. This shows my drive back. This is people who know the area. This is 280, and then this is 101, two different sort of spines that connect the city to the peninsula. The color of each dot, I don't know if you can all see it very easily, represents my stress at that point in the drive. So greens are I'm not very stressed, I'm relaxed. Reds means I'm pretty stressed. So I hope you can kind of make this out, but if you follow along, what's really happening is that as I leave work, there's a bunch of yellows, a bunch of reds, and they kind of go away halfway during the drive. Maybe I'm disconnecting from whatever stimulus I'm still running in my mind from work and so on and so forth. And this is really also my human sense of the world. So this digital sense of the world also sort of matches my human sense of the world. Well, let's look at what happens when I leave work in the morning. So those are all blacks. That's worse than red. So we were hearing about sense breaking earlier. This was a really sense breaking moment for me because this was not my sense of my morning. I'm excited to get up to, the problems I'm working on. I have a lot of energy. In fact, I have so much energy that during my drive, I am perhaps not making the most sort of safest use of email and phone calls and thinking about problems. And all of that is actually now reflected back to me with this digital sense. And the tyranny of the present of the commute is sort of, I have a chance to break it. And I won't talk more about the other layers that we sort of further investigated in this experiment. How does the audio that I listen to, how do the calls that I make, how does the traffic condition, the weather impact all these things? But with sensor fusion platforms, we had the ability to do that and actually change behavior. The final, for this little introduction, the final project is how do we make sense of personal health? So you may have seen these kinds of representations before. We call it a life board. One of these is a life board. So this is a grid of 52 dots by 90 dots. Each dot is a week of your life. So each row represents a year of your life. And we chose to have 90 rows in the life board. And so for somebody named Shelley that we did, one of the participants in anonymized name of one of the participants in our experiment, we sort of gave them an initial life board. So the average life expectancy for women is 81 years. So this dot says death. That's it. The red dot says death. And this blue dot is what day is it today? And there are some important events in their life in this initial life board. And the goal of this experiment was we all have, I saw several presenters on the here also have these wearables that tell us how many steps, our phones tell us how many steps we take every day. But that has not really actually led to a sense of how active we are in our lives and how much more active, how far are we from what we'd like to be. So we said, well, let's sort of give them the sense of the actual time that they have left in their lives and what that remaining time means for their current choices in wellness. So what we did was we took the computed risks of diabetes, hypertension over the next 5, 10, and 30 years and superimposed it onto the life board, sort of really leveraging this cognitive science principle of scarcity, and which sort of autonomously creates a response in you trying to address the thing that you feel a little bit scarce about. So here you feel scarce a little bit about time. Then we took it a little bit further and asked people, what do you really want to do with that time? How do you envision, your life 10 years from now, 20 years from now? And we said, well, I want to spend some time with my grandchildren or travel more, maybe in the summer, maybe around the holidays. And we said, well, we put that on the board. And then we said, nope, you can't do that because your data says and your risk says that you actually won't be able to travel to places that you will have a very different cuisine that you're used to because you have to manage your diet. And that really made that sense of scarcity that really sort of created a sense for them about what the choices they were making in wellness meant for them. So Fujitsu as a global lab operates in Japan and Asia. And what I talked about today is just a very small sliver of our perspective and the kind of work we are doing in various research projects. Thank you.
Thank you.
My name is Ryota Yamada from OMRON Corporation. And I was a visiting researcher of MediaX from 2003 to 2006. So I had a chance to work with Professor Cliffness about taking advantage of some social aspect. And we employ our social feedback to human, and we could successfully improve the performance of human. So according to that experience, I think it is very important to take care of human aspect in the technology. And now I'm working in the Open Innovation Initiative of R&D headquarters of OMRON Corporation. So now I'm very happy to come back to here to work together again with MediaX. And as some of you may do not know about OMRON Corporation, so I would like to explain about briefly. So OMRON is applying our sensing and control technology to many different areas of application. So biggest part is about industrial automation, and we also selling some electronical mechanical components. So in this components, so one example is some image recognition technology, including facial recognition. So such kind of technology is in our business. So we are also doing business about automotive components and healthcare business and social system business. So we are trying to create some sensing and control technology which can be used commonly in these different type of applications. So this is what we are doing. And OMRON and MediaX have very long and good relationship. So from 2000 to 2007, so OMRON was the first member of MediaX. Then after that, so there are some period. So we didn't have any specific project. But now I'm back to here. So and currently, so we are talking about creating next generation of new core technology for OMRON Corporation. So by using our sensing and control technology, so we would like to create new technology, which we call the technology to understand human. So as I already mentioned, so it is very important to take care of human aspect. So in comparison with machine to human, so human tend to be very different for everyone. So actually, I was in Thailand last week, but I found so the food not spicy for them is too spicy for me. So there are very big difference. And humans are also changed. So based on the time. So there will be some changes based on some emotional state or some health state. Or if we spend a very long time, so some personality will be changed. So when we take care about human, so with technology, so we need to take care about this difference between individual or changes based on happen from the difference of human state. And to realize such kinds of things, so what we are trying to do is we try to capture some vital signals using our sensing technology from human. So we can have many sensors, some wearable devices or many sensors. And by taking that data, so there are many good sensors, but we cannot directly sense the status of human. So we need to do some information processing using some artificial intelligence technology. And what we want to do is to distinguish the cognition or intent or many other things which cannot be directly sensed by sensors. So these are the one big challenge, and I think so. This is one aspect of making sense from the viewpoint of machine. And another thing is we would like to provide very good feedback to human. So when machine provides feedback to human, so we need to prepare the information to be well understand for human. So at that time, so we need to give some good we need to change the information. So adjusting for each person. So this is the big picture of what we are doing, and we are trying to apply this kind of technology in many different area. So one of the biggest area is factory automation. So to take care of the change of in hourly or daily changes. So we are thinking about so-called zero human error system. So in manufacturing line, so usually there will be some standard time, so which each workers have to follow, but based on some condition of human, so if something bad happened in the morning, so workers cannot work as usual, and in the evening, so workers may be tired. At that time, so we need to adjust the standard time, or we need to ask the workers to take rest. So such kind of feedback should be desirable to keep the quality of product or something like that. So to realize this kind of application, so we need some technology for technology to understand human, and we also have many have idea about different application, and we have many problem from customers, and to solve these kind of things, so we need some collaboration between the organization like MediaX. So I would like to do some open innovation so with you together. Thank you very much.
I'm going to go steer from the podium. So hi, everybody. I'm David Sirkin, and I'm an engineer and an interaction design researcher at the Center for Design Research over across campus. Our goal over there is to design interactions for smart devices, robots, and self-driving cars of the future. So in today's brief talk, I'm going to share just one of the challenges that autonomous cars present to us and some of our approaches to understanding and addressing that. This is a view of our simulator, which is across campus in the Automotive Innovation Facility. And so this is a video from a study that we're running now. And at the bottom, you can see we're capturing a lot of data on the car's controls, like the steering and the braking, and some of the driver's physiological measures, like our heart rate and our skin response. And in this case, our challenge is what happens during a long trip when the car is driving itself and the driver needs to resume control and make good decisions.
Shit. Okay, there we go. Shit. Automated driving is available in the left lane.
That first head bob was about 10 minutes in.
Exit the highway at the next ramp. Ooh. Wow. There we go. Wow. Oh. There we go. Back. There we go. Back. Oops.
So you see some of the challenges that self-driving cars might present. We capture a lot of video when we run our studies. It's often more effective at communicating the experience that somebody has during the study than the study data itself. We also code people's emotions. For example, we use software that can help make that easier. We look for sadness or surprise or disgust or fear. The thing is that facial expressions are part of how we communicate with each other. And when we drive, we're generally not explicitly trying to communicate with anyone. So it turns out that facial expressions work differently. So, for example, over on the end here, you might see there's an awful lot of disgust and fear and joy going on at the same time. So that basically means that we need to change the way that we interpret facial expressions for the in-vehicle context. One of our researchers, Sonia Baltodano, is working on just this problem. And this kind of observations led us to develop tools to help us assess situation awareness. So we've created an app that works like Waze, if you guys have ever used Waze before. It asks drivers about what's going on in the environment. The idea just being that what happens is much like with Waze, it says, gee, there was an accident reported here a few minutes ago. Is it still there? And we realized, wait, this is a great cover story for understanding how aware people are of the situation around them. And then we can use that information and mine it, understand how well they know what's going on, and then guide the car's behavior based on how well they understand what's going on. So one of our researchers, Nick Martellaro, had the idea of using a chatbot to use in the car on the road. And this version uses a remote operator, and you can tell because you can see him typing into the text box at the top left there.
I'm learning to pick the bottles, but I'm not that great yet.
Is it the workload or your mindset?
No, that's a good question. I think it's a problem of like a mindset.
And so the idea here is twofold. One is that we get feedback in the moment of what the driver is feeling and thinking. And second, that chatting acts with the car might mitigate some of the challenges that we saw earlier with the young lady with supervising autonomous systems. Turns out in aerospace, they've known about problems with supervising autonomous systems for a long time, and a lot of that just has not made its way over to the automotive space yet. And an interesting insight happened while we were chatting with someone about the car's driving. So listen for this lady's pause in answering the question.
Do you feel that car changes lanes smoothly while engaged?
It felt smooth.
So the way that she responded, it tells us something about how she's perceiving the world and what's going on. We learned that it was an inopportune time for that interruption. The driver was focusing on traffic while she was slowing down and avoiding other cars, instead of focusing on the question being asked. And so since we're collecting information about the vehicle, like you can see, we're hooked into the car's CAN, so we can see all of the in-vehicle data. We know GPS, so we know where she is. We've got cameras, so we can see the environment around. We know what's happening. We can look at all of that data and ask people questions. Is now a good time for me to ask you another question? Based on their response, we can then map out what circumstances make it good opportune times to ask and what are not. And then we can learn that over time. So if you've ever been driving in a car and it tells you, take the exit in 100 meters, well, what if you're busy moving around another car and you don't get that message? Maybe the car should have waited a few minutes or a few seconds before asking. So we can use that to better understand how the car can interact with the driver. And if you want to get in touch with me, behind everybody's head here is my email. And Wendy Ju is the executive director of our lab, and papers for all of the things that I was showing up here are up on her website. So that's it. Thanks.
Thank you,
I was already over.
Yeah, thank you.
I just wanted to see the videos.
We're trading.
Yeah.
Thank you. all so much for very fascinating talks. I was thinking as you were all talking that we designed the panel consciously to sort of move from the abstract to the more specific. But Brian, yours is really focused on the decision-making aspect and sort of assessing information. And you can correct me if I'm wrong in all of this. And at Fujitsu, it's technology, human and machine interaction for quality of life. Now, OMRON, I think that's the case also, but really focused on physiological sensor data. And with you, David, it's interactivity. And so what I'd like to ask, if you could each sort of talk a little bit about where the role of the human is for you in each of those sort of human-machine interaction, especially in the collaboration that is coming between the humans and the machines. So, and you can go in the order that you're seated, or however's natural.
We start with Ajay.
Sure. I think it's hard to overstate the role of the human, at least in the kind of research we do, because like Allison was saying, like in some of these new senses that digital infrastructure is trying to build, we don't even have good models of how human beings interact with these senses when they come to them from the analog physical world or from other people. So touch is a good example of that. We do some work on emotion analytics and understanding how conversations change. So especially in a healthcare context or mental health context, if a therapist or counselor is speaking with you, how do the various nonverbal things you perceive change your own ability to want to engage in that interaction further? So, and imagine layering onto that conversation things that a digital infrastructure has computed about what you're really feeling as you're going through this mental health exercise. So the role of the human being is sort of, all of our work is really anchored in understanding what they're doing, in what context they're doing it, from then being able to make some models so that we can predict what they can do, and in many cases influencing it, because oftentimes without that influence, they sort of fall into patterns or habits that perhaps they were looking to digital technologies to move them out of.
So context is really important.
Yeah.
Yeah. So, yeah, I agree that context is very important. So we cannot directly measure the internal state of humans. So we are measuring what we can measure through our technology. And when we see the human, we use some sensors, but and time duration or something like that. And if we can combine those data with some context, and we can understand many things. And currently, as ability of machine side is very limited, many people who have expert knowledge can understand by going close to machine side. Mm-hmm. But in the future, we think the machine should come close to human, and by understanding the context and human behavior, internal behavior, or something like that.
The question was something about people being.
What's sort of in the collaboration that's coming, or that's already here between humans and machines? How, kind of, where does one end and the other begin, or how do you think about that teamwork or that collaboration or potentially dependency? I just made it more complicated.
Yeah, I think you changed the question a little. On the collaboration between people and the machines, well, in cars for sure. We see that cars are very good, machines are very good at some tasks. They're very good at sensing the environment around them. Like, you can have this LiDAR that can look around and see a point cloud of a lady chasing a duck with a broom or something. And you can see all the way around you all the time, which people can't necessarily do. And you can react very quickly. People, however, are very good at other things. People are good at assessing uncertain situations, trying to make sense out of them. And so I kind of see things, at least in the context I was talking about here earlier, of a collaboration that leverages what each party does best, rather than try to have the car do everything, for example. And that's part of why we look, at least for the near future, at trying to understand driver state in case the car needs to call on the driver at some point to be able to do something that the driver does better than the car. So, and we see very similar things in our robot work. Like I said earlier, we also work with robots. We're big advocates of engineers trying to work with real people, other than engineers, when they're designing things. Maybe not all engineers are very good at getting out into the world or understanding situations from someone else's point of view. And they often have design requirements to have to build to. And then by the time the marketing group, who might interface with the real world, gets a hands-on thing, engineers are already locked in the system. So if we can push that interaction earlier in the design process, then we have a better chance to discover things like people fall asleep when they're monitoring the car. And much as we're told not to use our smartphones to send text and stuff when we're driving, when the car is driving, they actually help to keep us awake. So they're insights that you can't always get by engineering strictly in a lab that we'd like to see move earlier in that process.
So you need some field experiments.
Field experiments would be great. Lab experiments would be great. Just bringing people in and showing them your stuff even.
So how do you, when you're doing that and it's a collaboration, it's a teamwork, how do you think about the handoff? Like when it's the machine, when it's the person? And
yeah, I don't think it's a little. Okay. I think I felt more confident in terms of what exclusively is the domain of the machine and the human. I think today we've seen these advances in being able to move, in a sense, up this hierarchy, so to speak. But we do see these very interesting results of, JSB mentioned freestyle chess. There's another, this term centaur chess, where the human and the machine together outperform the human alone or the machine alone. That's particularly interesting. And does that apply beyond the more narrow domain of just chess in more open-ended competitions? There's work at MIT by Tom Malone and Anita Woolley at CMU on collective intelligence. It's really looking at teams of humans and how the composition of the team can contribute to the intelligence of the group. And of course, it's not just the sum of the individual IQs, by no means. So the interesting question is, as one develops those concepts, can one start to look at how one could, as now introducing machines as part of the team, and not just merely as there to take orders, but to be true collaborators, is an interesting question. Because we are going to see that the improvement there in cognitive capability of a machine as we, in a sense, improve autonomy from that respect. So those are actually, I don't think we're ready yet to answer that with authority, but it is a more interesting open question than I think it was just a few years ago.
Yeah. And as machines become creative, I mean, to me, that's the part that is...
Well, define creative, that's...
Well, exactly, but I mean, I thought that was what we could do. Like, that's our realm.
I know.
But, if we get there, then, who knows?
Well, we need to develop the seventh sense.
Yeah, exactly.
The brain needs to evolve in another way beyond what we can... It's an interesting... that's an interesting question.